All right. Well, welcome everybody to the to this session, our expert series. Today, we're very happy to welcome David Daniels of Tramex Meters to our forum here. It's going to be a very interesting. Well, it is an interesting topic. There's going to be great information on the subject. As the title says, it's $1 billion problem. And some would argue, actually, it's a $3 billion problem. For all of you flooring folks, it is not our responsibility to test concrete, someone else's concrete, Division 3's concrete, the general contractor's concrete. But it is our job under trade scope of work to verify that conditions are dry before we start troweling out adhesive. That is the responsibility of the floor covering contractor. So together, the general contractor and flooring contractor can absolutely work in unison to make sure that that $1 billion problem doesn't keep growing, which is what it's been doing for a long time now. And I think we've got the solution. We've talked to a lot of people. That's one of the reasons we've invited David Daniels here to talk with us today, is because there is a better way. So before we get into his session, just some typical housekeeping. If you want to ask a question, just type it into the bubble provided by Zoom at the bottom or top of your screen. And all these sessions are recorded. They're loaded onto our YouTube channel, which you can access through the NFCA site, or just go to YouTube and search for NFCA. That is all free of charge. All we want to do as an association is share good information. I think the best investment a flooring contractor can make, if you don't have a moisture meter, is buy one that we recommend. It'll save you so much heartache. Moisture failures are just so tough to deal with. So I'm going to also thank our national educational leaders. These are companies that sponsor these events and help us to put them on. Great companies, great people, great cultures, because otherwise they wouldn't think about putting money towards this sort of thing. They are visionary. I mean that. Ardex, Custom Building Products, Go Resilient Canada, Laticrete, Mapei, Merchant One Payments, Primco, Tega, Building Products, Tarket, Tramex, Uzin, and Wilson Embeck Insurance Group. If you're a retail shop out there, I'm just going to focus 1 second on Merchant One Payments. If you want to save $3,000 to $20,000 a year and have a zero cost quote to see if this would save you money, phone our office. We don't make any money at that, but I've watched it personally happen where the comptroller or the accountant of a firm says, no, we're looked after. Our machines work great for Visa credit card transactions. And then they get a quote and they go, oh my God. So if you use those credit card transaction machines, call us. We may well be able to save you thousands of dollars. They only do that through NFCA. Okay, so I'm going to read David's bio and then we'll get him going. So David is Vice President of Sales at Tramex USA. He's currently the he's the Vice President of Sales at Tramex Meters, has a strong dedication to the flooring industry and brings extensive expertise and a passion for delivering exceptional technical support to customers. I think that these underlying great technical support. His commitment to advancing industry standards is evident through his involvement on the ASTM FO6 committee that deals with moisture testing best practices. As a member, he actively contributes to the development and implementation of cutting-edge practices within the flooring sector. Recognizing the critical importance of staying ahead in industry trends, David spearheads the implementation of Tramex training initiatives throughout North America. He places a special emphasis on advocating for, in brackets, time of install moisture testing. That is critical, I think, to your message today, right, David?
Yes.
Concrete in particular, and wood as well, ensuring that professionals are equipped with the necessary tools and knowledge to make informed decisions. David continues to make significant contributions, driving growth and innovation within Tramex Meters and the broader flooring community. David, my friend, over to you.
Thank you, Chris, and the NFCA, and I just want to thank everybody for joining us today. It's a great title that Chris came up with, kind of a supermarket tabloid title. So hopefully it captured some attention. I know we had a couple emails with people that were a little alarmed by the title, so that's good. We're hoping they're here to get informed on the topic today.
I'm a strong believer in keep it simple, stupid, right?
Yeah, me too. And the implementation of logic is key. So we can go to the first slide there, Chris. So what we're looking at today is the implementation of time of install moisture testing. And the topics we're going to go over, we'll touch first on some points of 2170. We'll get into the complete concrete moisture testing system, time of install test, look at concrete profile, dew point, look at the concrete moisture meter and the VTT study, how to execute the installation quick check or time of install test, what to do or how to correct a dew point issue. We'll look at the meter testing gypsum and cementitious screeds, and then get into the app that we provide in order to be able to document findings at the time of installation. Next slide. So ASTM F2170 is the standard test method for determining relative humidity in concrete floor slabs using in situ probes. So I'm sure many of you are familiar with this moisture test. It's become pretty much the standard. It's usually specified next to a calcium chloride test, and the option is given of which test to do. And then that's generally the only specifications we see for moisture testing. Now, important points that I immediately noticed examining F2170 and talking with different customers when I first got into this business was this point here in section 5, significance and use, 5.3 specifically says moisture test results indicate the moisture condition of the slab only at the time of the test and in the specific locations tested. So that's important because most times the F2170 test is conducted to qualify the slab to receive a floor covering. So it may be a week, it may be 2 weeks, it may be a month before installation actually happens. So keeping in mind that even this test itself is informing us that those readings were good at the time they were taken. Next slide, Chris. So it behooves us to understand that at the time of install, those conditions can change. Now, Tramex has always recommended a complete test of not just one, what I like to call vital sign of the concrete slab, but looking at what we consider the most important 5 vital signs to understand the moisture condition of a concrete slab. So this is what we recommend as a pre-test. Sometimes we call it the 5-point test. And it involves, first of all, a hygrometer to understand ambient conditions, which is very crucial as ambient conditions have a direct effect on a concrete slab. Many people feel like when a concrete slab is dry, it's done, I don't have to worry about it anymore. And I think that's part of why we see a misuse of the F2170 test. So a concrete slab, like a piece of wood, has a variable moisture content. Now, when we're dealing with construction water on a new slab, that's one thing that we want the construction water to all evaporate or to be utilized to create the cement and create the concrete. The condition of the slab, the moisture condition of the slab will vary according to, especially to environmental conditions, because a concrete slab can pull moisture out of the air and then it can release moisture back into the air. So always
got a comment, David. It just surprises me how the industry focuses on the internal condition of the slab and not necessarily on the surface, when
Yes,
it's obviously the surface that we're sticking our adhesive to.
correct. And
It'd be
the
the other
interesting
way
thing
around.
about, yeah, the interesting thing about that point too, Chris, with the 2170 in situ RH test, if you analyze what's happening here, we're isolating an airspace down at 40% depth of the slab. So you're completely cutting off ambient effect.
Yeah.
And that's why the need becomes to do other testing to understand if there is some ambient effect. So going through this test again, after we check and document all the ambient conditions and noting dew point, then we take surface temperature of the slab. Again, making sure that the surface temperature is at least 10 degrees Fahrenheit above the ambient dew point. Then we take a reading with the moisture meter following F2659 as a guide to how to do our drops, which we'll get into later. And then after drilling the hole to do the in situ RH test, we recommend using the concrete moisture probe, which also gives a moisture content number down at the same depth that you're drilling for the in situ RH probe. And then finally to put the sleeve and cap it so that you can come back in 24 hours and take your in situ RH readings. So this is what we consider, a full exam, so to speak, of the concrete slab. Next slide. And this is generally, again, done as a pre-test. And then we recommend at time of install to go back over those 3 first points of the 5-point test. This is what we call the time of install test, or the installation quick check for concrete. And you're looking at the 3 first vital signs. Again, ambient conditions, noting dew point, surface temperature of the slab, making sure it's at least 10 degrees above that ambient dew point, and then the moisture content given by the concrete moisture encounter, which is going to be a percentage moisture content number between 0 and 6.9. Now, the reason that range is there is because 7% is saturation as far as these percentage moisture content numbers go on concrete. So
according to your equipment, not necessarily for everybody's equipment.
Correct. So generally the number, the dry number is 4%. So you want to, get a gauge of that. And one thing to understand is that number, it doesn't care where the moisture came from. So the beauty of the meter is that it will pick up ambient moisture that's been drawn into the slab with a high percentage moisture content reading. And this is what, in the past, people tried to disqualify our meter, saying, well, it's not really giving you the actual moisture content of the concrete because it's showing you the effect of the ambient condition. But we want to know that. As someone installing a floor covering on top of that, I want to know what the moisture content is now in this piece of concrete that I'm going to glue to.
Because if you don't and you prove things are dry at the surface, say at 3 o'clock in the afternoon, and you leave site, well, by 6 o'clock in the evening, ambient conditions could have changed and completely saturated the surface of the concrete. Is that right?
Yeah, correct. And conditions can change fast. I'll get into another slide. I'll give a little anecdote about that, but that's the main thing to understand is that just like a piece of wood, the moisture content is not stable. It can fluctuate. And that's why ambient conditions are such a great effect on the moisture condition of the concrete slab. And specifically, that's why even with F2170, it's recommended that the slab is in service in an area of service condition, meaning HVAC is on and the interior ambient conditions are in a controlled state at what they'll be once the building is occupied. And
sorry, for those who are sort of find dew point to be a bit of a mystery, I like to call it condensation point. And if you just apply the same rules that generate condensation on the inside of a pane of window glass in your kitchen when it's warm inside, cold outside, and it's humid inside also, it's the exact same thing, only we're dealing with the surface of concrete.
Exactly. Next slide, Chris. So this here is a side view of a concrete slab. And the benefit of us seeing and understanding what's happening here is that from the profile view, we can see that the consistency in the slab is not equal throughout the slab, or the permeability and porosity. As you can see up towards the top, so this blue arrow is representing the space above the slab, and we're kind of looking at a cross-section picture. So the area up towards the surface, you can see it's much more porous. There's a lot more black spaces there. And then the red, that's the red arrow. So and that comes from improper curing, which is most of the time, because everybody's fast tracking to for construction, and that leads to improper curing. I won't get into those specifics right now, but that's what we're seeing in the field. The white arrow shows a void in the slab. So we get those air voids in the slab, and those are the areas where we're testing relative humidity. Actually, we're creating another void like that and then enclosing it and testing relative humidity when doing F2170. And then the gray area shows the concrete interior, or towards the middle of the slab, or at the 40% depth, where it's much more dense, which is a different situation than up at the surface, which the point of this slide is to show us that this behooves us to take readings at the surface, not just in the middle of the slab, especially because that's where our product is going, at the surface of the slab. Next slide. So dew point and condensation, as Chris was referencing a little bit, so people can understand that better. This is a picture here of a basketball court. And what was happening here was the basketball court was getting condensation on the surface as they were getting ready to play the game. This was a situation where there was a ice rink below the wood floor, which is representing, for all intensive purposes for us, a cold concrete slab. And the surface itself of the wood was also cold from that. And then the humidity increased as people were coming into the arena, and it created this dew point issue that they couldn't stop the condensation from forming on the surface of the court, and ended up having to postpone the game. Now, real world, where this translates in the flooring industry, is, say you have a situation of a slab in a area that the HVAC isn't controlled, or it's partially controlled. You get a cold night and a warm morning. Well, the cold slab is going to take longer to warm up than the air. So the air is going to start heating up faster. And now imagine you get workers starting to come into the job site. Now the relative humidity is going to go up, but the slab is going to lag in catching up to the air temperature. Generally, a concrete slab is 1 to 2 degrees cooler than the air in a normal condition, but that concrete slab is going to take longer to catch up. And if the guys go out in the morning, do no moisture testing, just start installing on that slab, you're going to have a dew point issue, and your adhesives aren't going to stick, or you're going to trap moisture under there. Next slide.
I just was going to say, and all that dew that's forming on that basketball, that condensation on that basketball court, you see it there because it's got nowhere to go, but with concrete, it's just going to soak in and disappear.
Exactly. I like to give people the example of a sidewalk. If you watch a sidewalk when it's raining, some parts of the sidewalk will just absorb the water. Other parts, you'll get a puddle. The reason you're getting a puddle is because the concrete is saturated. All those pores are filled with water. Now there's no more place for the water to go in the slab, so it forms a puddle on top, right? So that's the trick with concrete, is that we can't see it like they're able to see it on the wood here, because it's soaking into the slab from the air. So the naked eye won't pick it up. It's soaking in as a vapor and then condensing up in the surface of the slab to turn into actual liquid moisture. And that's another good point about our concrete meter, is it's picking up liquid moisture. not looking at vapor, but looking at liquid moisture. So as that vapor condenses, it turns to liquid and can be picked up by the meter.
Yeah, I mean that brings up a good point. If you're a manufacturer that just calls for ASTM 2170 relative humidity in situ drill test, and expect that to guarantee there's going to be no moisture issues, you're in for a surprise. You're rolling the dice, because that test does not cater to the surface or this dew point.
Correct. And as you can see, actually, with that, when on the previous slide, it's going past the problem area. So the problem area is that surface because it's more porous. And the other thing that's happening when concrete is curing is the salts are going to the surface and settling. So as the salts settle on the surface, that alkalinity can also act in a way of drawing moisture from the air. And that's why we put that 10-degree cushion there. That 10-degree Fahrenheit cushion is for that particular fact, is that the concrete can start to draw in moisture before it actually hits dew point, right? So if you looked at a grassy area, you're not going to see dew on that grass until it actually hits dew point. But the difference with a concrete slab is because of those salts, they'll pull moisture out of the air. I don't know if any of you guys are familiar with the product Damp Rid, but I've seen more and more commercials for that product, Damp Rid. Or you could think of when you buy shoes, you get a little white packet in the shoes. Sometimes in other products, you see a little packet in there, and that's got salts in it, which is sucking moisture out of the air. So they put those packets in shoes and things to make sure that there's no moisture issues in transit or in storage of the shoes. So same idea with Damp Rid. It's a product that's used. You can put it in a damp space and it'll pull moisture out of the air. But that's what the concrete slab is acting like when it has an alkaline surface or when those excessive salts are at the surface of the slab. So that's the reason.
Absolutely dry surface with a high pH and the potential for it to be soaking wet because it's going to draw moisture down from the air to the surface. It's attracting it.
Correct.
Interesting. And the pH test almost becomes like a warning. You got a dry test.
But the only problem with the pH test, Chris, is that people tend to consider pH and alkalinity to be the same thing. Yeah. But the difference is the alkalinity is the condensation of those salts. So the pH test alone doesn't give us the alkalinity of the slab. Right. And this is why the main thing, this even came up recently in ASTM meetings as they were deciding whether to get rid of the pH test, keep the pH test, require that you use a pH meter instead of strips, yada, yada, yada. But the ultimate point of that is if you don't have moisture, then your alkalinity won't be a problem, right? If you do have moisture, it's going to be a problem because it creates osmosis.
What about if you've got moisture in the air and you've got a high pH but dry surface? You've got a potential problem.
Yes, for sure. Just I had a situation. I was doing some training in California. I think it was Sacramento area, and for a dealer, and we met at a conference table and talked about this same kind of thing we're talking about today. And then I said, let's go out in the warehouse on the slab and bring the meter, and we can all look at what the meter's doing. So there were about maybe a dozen installers in a circle, and it was an old slab in the warehouse. So they ground down an area in the center, a big circle. I actually pushed the meter on the slab before they ground down that area, and I got 2.9% moisture content, which is kind of normal for an old slab. It was about 20 years old.
Just to say, ground down. Your meter looks for 4 as the point.
As a dry number, yeah. So you want to be less than 4.
So 2 point something is good.
2.9 is a good number, and then they ground down this surface. I put the meter on the surface. I got 2.9 again. So now I pass the meter around and the guys are looking at it while I talk and going through the things. We get to the second from last guy and he says to me, well, if Jose goes on Friday night and does this moisture test, And I go back Saturday morning, do I have to do the moisture test again? And I said, I don't know, put the meter down and see what you get. Not knowing what he would get, but he put the meter down and he got 4.6. And that was in less than 15 minutes.
Yeah, yeah. Wow.
So, and then we checked and there wasn't a dew point issue. We did have the dock door open. So obviously we were pulling some humidity from the outside, but we didn't have a sighted dew point issue. But what it was is that 20-year-old slab was very alkaline. So as we took off that polished surface, we exposed those salts. And then the salts acted like damperid. They pulled any moisture out of the air that they could grab. And now they're up, your number's up to 4.6, where it's a problem.
That's a great example.
And it was like, yeah, I mean, I couldn't ask for a better real life example to show these guys, but everybody was astonished.
Yeah.
And that's the nature of concrete, is that you can't predict and you can't say what it is now, it'll be in 15 minutes. And that's why we say, again, we're emphasizing time of install testing, and not just testing when I start my install, but testing during install. As you get into different areas, as throughout the day, you start to install in an area again, drop the meter again. It's giving you instant readings to understand what's going on. So you can immediately, if you drop the meter and you all of a sudden you get a high number, wait a minute, stop, what's happening here, right?
That's why it's always been for decades in the scope of work for floor covering installer to do that last minute check. With a,
yes.
Sometimes it was a sheet test with a piece of plastic, as simple as that.
Yeah. And now the beauty of the meter is that I don't have to wait, and it's instant. So I'm going to instantly see what it is now,
right?
You know, which is ideal for when you're starting to install. But it is also important for this pre-test that's done. We say, you know, instead of the person going out to do the pre-test that's qualifying for the installer to come do the installation, instead of them just looking at one vital sign, it's also beneficial for them to look at these other vital signs of the slab. So for them to understand the moisture content as well as in situ relative humidity is all the more benefit. Why? Because it helps us to understand, why do I have high moisture if I have it? So instead of just saying, oh gosh, I have high moisture, mitigate, which, you know, for some people that's the idea, if you're selling mitigation. But for the end user who doesn't want to waste money in an already expensive process, they appreciate more when the technician or whoever is doing the moisture testing can understand, if we have high moisture, why do we have high moisture? Is it something that we can correct, or is it something that we have to mitigate?
Yeah.
You know, and then it's a clearer and more honest analysis. Next slide. So this is the concrete moisture counter, the newest version of our concrete moisture meter. And the technology, the basic technology we're using here to get the percentage moisture content of concrete has been around with Tramex within the concrete moisture encounter for more than 20 years. So it's unfortunate that it's taking this long for people to start to understand, for whatever reason, but percentage moisture content, we know, is the ultimate way to understand the moisture in any material. So just like when we look at moisture in wood, that's just the standard. Everybody's looking for the percentage moisture content of the wood. And we understand if we utilize the specific gravity based on the different species, that we can get an understanding of the percentage moisture content with a moisture meter that was calibrated based on gravimetric testing. So gravimetric testing is oven testing. It's used throughout all different industries to understand the moisture condition or moisture content of different products. So it's pretty much the gold standard in moisture testing. And the beauty of this meter, the value of this meter, is it's able to give you percentage moisture content of the upper 3/4 of a concrete slab. And this is giving you, again, a look at liquid moisture as opposed to vapor. So when you put it alongside of an F2170 test, it's ideal for initial testing for sure, because you're looking at moisture in the different forms. and in the different areas of the slab. And this slab we call the bond line. So this is where you're going to bond your product to the slab. So it's of utmost importance to know the liquid moisture content. Next slide. This is, and then the ultimate question is, well, is the meter valid? Is it telling me the moisture content? And there's been a great effort by others within the industry based on, generally vested interest to try to discredit this meter. And that's part of the existing condition of the ASTM F2659 standard, which we're working on to get adjusted language in there so that it can be specified alongside F2170 and F1869. This is a test that was done back in the year 2000 with our concrete moisture encounter. Again, the same technology that's in our latest version of the meter. And it's showing, it was done by the VTT in Finland. And the reason for their test was they were looking at the best way to analyze concrete in bridge decks. So again, our concrete moisture encounter was used or tested alongside other test methods. So you see them listed here in the top portion of this chart. This is the 28-week or 28-day test. And relative humidity at 95%. And then you have 2 readings from GON, 2 from Protometer, 2 from Tramex, 2 from Humitest, and then the oven test or gravimetric test. Now, the width of these black lines is the variance or repeatability of the test. So if I keep putting the meter down, is it showing me the same thing or is it varying? So as it varies more, you get that bigger black band. So again, the gold standard is this bottom oven test. So looking at the top chart, that bottom square of the oven test is going to be the gold standard. And you see Tramex here. The top portion is the standard clean bare concrete. Bottom portion, or sorry, it's opposite. Top is the polished concrete, and the bottom is clean bare concrete.
Can you see my cursor there?
Actually, within this, meaning that it lists Tramex or each type twice. So you see Tramex and Tramex again. The first listing is on a polished piece of concrete. The second listing is on clean bare concrete. So both charts, top and bottom. But then you see how we line up with the oven test. So that's ultimately this bottom square that your cursor's by, lining up with that bottom square of the oven test is showing how accurate the Tramex meter is.
Yeah,
and
so
looking
this is the gold. This is the standard right here. This is a bad result, and your Tramex is coming in very close to the standard that we want. That is,
and the repeatability is showing that it's not wildly inaccurate, but it's accurate.
Yeah.
And repeatability. And then in the bottom chart, you even see it's tighter in the clean bare concrete. Look how tight and dead center that is with the oven test. So we don't recommend to use the meter on polished concrete, but as you can see from the VTT study here, it's going to vary your reading about 0.5% in the numbers here. So this is just showing, it's an independent study that was done by a very prestigious lab in Finland, and it's showing that our meter is valid in giving percentage moisture content readings compared with gravimetric testing. And that's the bottom line that we want to know. Is it giving us valid information repeatedly and accurately? Next slide. So now when we look again at the time of install test, which we also refer to as the installation quick check for concrete, or the 3-point test. Actually, we came across this test method from an old timer that has he's actually located in Florida here, over in Melbourne, Florida, which is near Cocoa Beach. Probably more of you know that location. But he's a guy that does concrete coatings, and he's been doing it for, I think, 50 years or something. Maybe not that long, maybe 40, but does a lot of work for SeaWorld, coating underwater tanks, etc. And we met with him about I think it was 2019, beginning of 2019. Not myself, but Andrew and Bob Higgins met with him, and he actually gave us this 3-point test as his method of making sure that the concrete was able to receive a coating. And it's brilliant. He actually told us of a story where he used it on at an Air Force base where they were putting a coating in the hangars for the airplanes. Obviously, they're open to exterior ambient conditions, and nobody could figure out why the coatings continued to bubble. He went in after the fact, after 3 companies had been there, utilized this 3-point test, which it was called at the time, and solved their problem and successfully installed the coatings with no bubbling. And he says he's used this in a variety of situations. Now their thought process is they take a little tighter standard. Usually 3.5% moisture content is their number, but their goal is to manipulate the concrete to get it to that number. And you can manipulate the moisture in the concrete just like the concrete is affected by ambient conditions drawing in moisture. You can artificially manipulate the slab to pull the moisture back out of the slab. They would do that using fans in most conditions and continue to test until they got the number down to 3.5 or less, start installing their coating, following the fans, making sure they're at 3.5 everywhere they put the coating down. And once they get that to cure with that 3.5% moisture content, he said they were bulletproof. And we see that even with a lot of the adhesives today. If you do your own test, get something to cure properly, you can throw it in a bucket of water or throw it in the pool and take it out tomorrow, and that bond won't change. So very important here. In this test now, the 3-point test, again, the first point that we recommend in this test is gathering the ambient conditions. The beauty of this meter, this concrete meter, it has a hygrometer built in. You don't have to think, you just have to look. And across the bottom, you'll see temperature, relative humidity, dew point, and then the fourth one is one that we don't really use in the floor covering industry, grains per pound, if you want to get more specific. So this is very vital information at the time of install, not only for the installer or whoever's there conducting the test at the time of installation to gather, but to also document. And I'll get into our app later, but it makes it very easy to document this information and save it. So again, first point, we're looking at ambient conditions. We're going to make a special note of the dew point temperature and for comparing with the next step. So next slide, Chris. And the second step of this process is looking at the surface temperature of the concrete slab. Now, again, people might have that common knowledge that the slab is generally 1 to 2 degrees cooler than the air, but don't assume. We know what happens when we assume. So the whole purpose of moisture testing is that we want to look for the problem, right? So we don't want to assume anything is anything. We want to check these things and make sure there's not a problem lurking that we're not checking. There's a good example. It's just like when we do this test, we want to keep highest numbers, not average. So some people think, well, I'll take the average, but we're going to keep the highest number we document, right? And the reason for that is we don't want to average because the analogy that I'll use Bob Higgins' analogy is that if you took your head and put it in the oven and had your backside out on a slab of ice, the average temperature would be perfect, very comfortable, but you'd be very uncomfortable. So just like that, we're not going to average anything. We're going to take the highest numbers when we're doing moisture testing. So again, second point, we're looking at surface temperature, generally with an infrared thermometer where you can just point and shoot. And you want to make sure that it's 10 degrees Fahrenheit above that ambient dew point. Now, some people will say 5 degrees, or that's out there in literature. But basically that's based off a British standard, which was listing it, the dew point test in Celsius. So in Fahrenheit, we're going to say 10. Next slide, Chris. Then the final point, the data point that we're going to collect with this time of install test, third point, is the percentage moisture content. So again, the concrete moisture encounter depressed to the surface is going to take a read about 3/4 down into the slab, and it's going to give you the percentage moisture content or liquid moisture that's up in that 3/4 inch of the slab. So generally, again, 4% is our dry number that we're looking for. We want to be 4% or less. Now, we should also be cognizant that whether it's a new slab or old slab. And we always define a new slab as a slab that's never had a floor covering. An old slab is a slab that was covered and you're changing the floor cover. Newer slabs, you're dealing with construction water, obviously. So the water that's in the pour, now it needs to evaporate out. So you're just leaving the water that's there to continue to form your slab. Next slide, Chris. So following ASTM 2659, we recommend that when taking readings with the concrete moisture encounter, you're going to take 8 readings in the first 1,000 square feet. Okay, so if you have a job that's 1,000 square feet or under, you're going to take 8 readings throughout the area. You're going to spread them out, and you're going to, again, keep the highest reading. Next slide. When you're taking your readings, it's not that you just push down straight and take the number, but we always recommend in each test location, you're going to take 4 reads. And we kind of say to go around the clock or around the horn. So you're going to take one at 12 o'clock, one at 3 o'clock, one at 6 o'clock, one at 9 o'clock, and then you're going to keep the highest number in that 4 reading area as your first reading, and then go to a next area. So each area, you're doing 4 drops and keeping the highest number. This just generally helps to make sure that there's no weird anomaly that's happening there. And again, you want to be doing this on a clean, bare piece of concrete. So if there's any paint, drywall, mud, anything like that, you want to remove that in the area you're testing. Next slide. Now, if you do get a dew point issue, so if you have a surface temperature that isn't 10 degrees above the ambient dew point, or if you have a high percentage moisture content, in this case above 4, we want to try to understand why that's happening. Generally, if you have a high percentage moisture content reading, the most common thing to rule out is ambient moisture, right? So you'll see it correlate in the first 2 test points with the 3rd test point if it is a dew point issue. Now, if you get a high read and you don't cite a dew point issue, we generally recommend running fans as your first measure to try to pull that moisture out of the slab, because of the example that I mentioned of where I was on a slab and I didn't have a cited dew point issue, but the slab, because of alkalinity, was sucking moisture out of the air. So generally, fans running across the surface of the concrete will make some difference in the moisture content within about an hour. You'll start to see that moisture content go down if it is ambient moisture that's been drawn into the slab. Now, keeping in mind that you obviously have to have a place for that moisture to go in the air. So if you're in a situation with a really high relative humidity and you're still in a dew point issue, sometimes you would need to implement dehumidifiers if you're going to try to correct it. Now, this is where it comes to at least you understand what the condition is and whether to mitigate or to try to correct this issue. I will say that, especially in bigger projects, as we know, mitigation is expensive, which is good for somebody, bad for somebody else. So generally, if you're trying to get to the real truth of the moisture condition, you want to know where that moisture is coming from before you blindly mitigate. And that's just a good practice. If I personally believe in what goes around comes around. So if I'm cheating people by selling unnecessary things, I think that's going to come back at me, but you know, so what we want to do is allow for an easy way to get a true analytic of the moisture condition of the concrete. And this, by implementing, ideally, the 5-point test as a pre-install moisture test method, and then repeating those first 3 steps at the time of installation, you'll realize how many problems you nip in the bud. Because otherwise, if you're just doing this initial testing and doing no further testing, as you can see from this information, it's almost useless. It's a bit of a roll of the dice. And as we know, in situ RH testing is not cheap. So it's terrible to go through all that time and expense and endeavor, and then to not follow it up with any time of install testing. Next slide, Chris. I mean, a slab idea. The concrete moisture encounter is also excellent for getting the moisture condition for gypsum. So there's two scales that you can use on the meter. And this first one, I put it first because it's the one that's seen a lot in the different gypsum manufacturer specifications. So for gypcrete and so forth, generally you'll see 0.5 given as the dry number, saying that you want to be 0.5 or less. Now, within the reality of spec writing and copying and pasting and misunderstanding, this is how I came across this scale as being applicable within our meters to the specifications that these manufacturers set, because I had somebody call me and say they had a concrete moisture encounter, they were on a big job, and they were trying to get to 5% or less, not 0.5. And that's alarming, because gypsum is an anhydrite. So anhydrite means that it dries out completely. So different from concrete, it's not supposed to hold moisture. It's supposed to go completely dry. So that's why we're trying to see where the moisture is gone, before it's ready to take a floor covering. Now, the other benefit of this meter in testing a gypsum material is that the read is going 3/4 down, and it's going from front to back of the meter. So you get a pretty large test sample, as opposed to trying to drill some holes and push a pin probe into that gypsum, where you're only getting a read at the tip of the pins between the tip of the 2 pins. So that's a very small test sample. So it can sometimes give inconsistent drying information of the gypsum. Next slide, Chris. And then we have the Tramex gypsum scale, which you can also use. I don't believe I've seen any manufacturer specifying it, but it's made for ease of use for an installer, because it follows the numbers of concrete. So using our Tramex gypsum scale on gypsum, you want to be, again, 4% or less. And the reason Tramex designed it that way was, again, for simplicity. So if on concrete, I can put it on the concrete, and I know I should be 4% or less. If I'm on gypsum, I just put it to the Tramex gypsum scale, and I know I should be 4% or less. So for that simplicity. But again, it's important to ultimately understand that the gypsum, we want it to dry out completely, not that it holds water like concrete. Next slide. So the other benefit of the current concrete moisture encounters is that they connect to the Tramex Meters app, which allows you to easily document the data that you're taking. So that what you're testing for at the time of install, now you can document and save very easily within the app. You can actually do this without even having to write any readings down. So the app is able to give you a look of the meter screen, as you see here in this slide. So it's showing you the percentage moisture content from the screen and the ambient conditions up on the phone. So you have that information in the palm of your hand. But it also allows you to take pictures of any readings or any conditions, which will automatically be geotagged. So they're going to tell you the date, the time, and the place that the picture was taken. And then all these things can be saved and put into a file to keep with your job file should anything come up down the road or in the future and there's a failure. Now you can pull out your moisture tests from the time of installation to show what conditions were. And I can't tell you how much of a difference that'll make in documenting this data at the time of installation. Next slide. So the feature here is our moisture mapping feature. And what I touched on before was being able to save your readings without even having to write anything down. So you see here on the phone screen, there's a grid. That grid, you can control the size of the grid, the size of those squares for your testing locations. You can also put that grid, you can overlay it over a photograph, which can be a photograph of a floor plan to show where your test locations are on the floor. I had one guy who was super zealous and he flew a drone up into the ceiling to take a picture of the floor and then put this grid over that actual picture of the floor to show where his test locations were. But again, the beauty of this is you can very quickly. So, we understand that at time of installation, installers want to start installing the floor and they don't want to waste too much time. But you don't want to waste all of your installation time either installing something that's going to fail. So if you take a little bit of time here, you don't even have to write anything down. You just walk through with the meter, you press and tap. So you're going to push the meter to the surface and tap and save your readings. Now you have the ability to save just the moisture content or the moisture content and all the ambient conditions. Or even if you just save the moisture content, because the ambient conditions are embedded in that reading, you can always go back and pull the ambient conditions, even if you didn't elect to save them in a visual way along with your percentage moisture content reading. So I can't stress what a difference this will make, because I hear all the time after time, of inspectors going out to failures and there's zero documentation of what conditions were at the time of install. So then at that point, for an inspector to accurately assess why this failure occurred is next to impossible, because he cannot rule out dew point without understanding what the ambient conditions were at the time, and the moisture condition of up at the surface of the slab. So what this will do for the industry is, I think, incomparable to what we've seen so far in moisture testing. It's allowing you to easily, again, test at the time of install, document your data, move on, install your floor. If a failure does come about, it's easy for you to pull this information up and show, hey, it's not my fault. At the time of installation, everything was good as far as moisture condition. So, and dew point. So this is valuable information, a very valuable asset to anybody installing floor covering. Next slide. I don't know if there's another one or, oh yes. So the calibration check plate here is also very important to verify that the meter is in calibration. Obviously, if a failure comes and God forbid it goes to litigation, and then somebody tries to say, well, we don't know if the meter was calibrated. I suggest that people do this before they start any moisture test. It'll take you less than 3 minutes. It's basically putting the meter on top of this calibration plate, which shows that it'll get a 4% plus or minus 0.1% if it's in calibration. You can go to the take a picture mode in the app, take a picture, geotag it, bam. You have valid evidence to show that the meter was in calibration as you began moisture testing. So again, this app just provides ways for you to safeguard the installer or whoever's testing at the time of installation. And for too long, I think installers get a target on their back because they're the easy target when there's a failure. They're the last guy on the floor. Everybody's going to go to the installer first. And when they go to the installer and he's able to say, boom, I'll just email you all my moisture testing data from that job, and he can move on and know that he's protected. Next slide. I think that might be the end. So that's the end pretty much. Thank you guys for sitting through and listening. Happy to answer any questions you might have. Again, it's a very easy implementation. Doesn't take a lot of time. Everybody obviously is concerned about cost. But when you compare the one-time investment of something like this, as opposed to, buying one-time use RH probes over and over and over and over and over again without doing anything else, it's kind of a no-brainer. Even for an installer, I understand it's a big investment, but one failure is going to be much, much more expensive than the cost of a kit. So any questions, I'm happy to entertain. And thanks again, Chris, for providing the opportunity. I think you're muted, Chris, if you're talking.
And yeah, thanks, David. Great information and well presented. It's such an important topic when you consider the size of the problems out there and how difficult they are to resolve once we go ahead and install as flooring folks. David, if you read the bubble, click on the bubble at the top or bottom of your screen where it says chat.
Yes. Oh, I can see the questions. Okay.
Then you can read some of them. Probably need you to read them as it's easier that way.
Okay, first one was Angela D. She said, not to mention other trades like drywall and paint adding humidity, for sure. So as guys are opening, and even this even goes to the same guys that are there to install, as they open a bucket of water-based adhesive, it's just everything, all these things are adding, increasing the relative humidity inside that installation space.
We used to get away with a lot of this stuff because of the petroleum-based adhesives.
Yes. And it's definitely made things a little more difficult as we've become more environmentally conscious. There's some other things we have to be aware of at the time of install, for sure. Clayton Shaw said, why are there 2 Tramex tests per chart? So I think I answered that, but maybe it wasn't so clear. But there's, again, one is for polished concrete and one is for a clean bare slab. So they did both side by side to kind of get an idea of how much that polished surface would throw off the test method. Clayton also asked, do you think that when you do moisture content tests at 180 degrees to each other, such as 3 o'clock, 9 o'clock, or 12 o'clock, 6 o'clock, wouldn't result be the same, since the flexible feet would be in the same position? So it kind of depends how you might not spin it off that base point, but pick it up and move it kind of in that one area. So then your test area becomes like this little, maybe 6 by 6 inch square or something. And I have seen personally, by rotating, that you will get different numbers from 3 to 9 o'clock or 12 to 6 o'clock by a little bit. So again, you're going to take the highest number in that rotation to be safe. Clayton also said, I missed the first half, but did you talk about the different attachments, such as dual pin probe for 500 species of wood? So good point. I didn't mention that, Clayton, but that's one of the features of the meter that we showed here, is that you can do different attachments. As you saw in the 5-point test, you're attaching the probe for doing the in situ RH test. So we do have other types of probes. The one he's referencing here is specifically the 5/8 inch pin probe that allows you to test over 500 species of wood. So you can designate the wood species and then do a test with the pin meter. This one is from Jim Gorton. So he says, on a particular healthcare project with the above assembly, the slab also had cross-linked polyethylene hydronic lines for heating, cooling. Even after careful surface moisture testing and prep, the flooring, a premium wide format vinyl with welded seams, failed and bubbled in many areas. Is it possible the plastic hydronic lines, let vapor gas out of the water in the pipe and cause the floor failure. Definite possibility. I mean, it's hard to give any analysis from my couch here, just based on that information. But that does add another element, obviously, when it's not just the slab, but you have some interior. He also says, worth mentioning, the slab was on a metal deck. So the moisture can only go up through the top. Yeah, and I'd imagine the metal deck was pretty far down there, but good thing to keep in mind is metal will peg a reading on an impedance meter. So if the meter hit metal, it'll bury the needle, or on the digital meter, put it to 6.9. Now, some people try to say, well, that's why it's not good. It could be thrown off by rebar, but rebar should be at least an inch or deeper into the slab, I would hope, in any healthy slab. But if you do see, that's again why you're looking for anomalies like that when you're doing the 4 drops in the one spot, to look out for these kind of weird things. I think that's all the questions I have here. I don't know if anybody has anything else.
So, David, if your test comes into contact with metal and
Yes.
throws the meter off, what does the meter indicate?
The indication on the meter is it just buries the number. So if you were on our analog, the needle will be buried at as high as it can go. If it's on the concrete meter, it'll be as high as it can go.
Okay, so it just goes off the scale.
Yep, correct.
Okay. Great. Well, if there's no more questions from the audience, I think we'll thank you and let you go, David. That was great.